All right, we're back. So I'm gonna continue this series where we follow the LLVM tutorial. That's on LLVM.org. We're at the end of chapter 3 and near the excuse me, near the end of the last episode. We hit a snag. We got the program to compile, which was not easy. But once we got it to compile, we ran it, and the moment we throw something at it, it sig faults. So we're gonna need to debug this. Um, I do want to show you or anyone else who might be watching how to debug C++ code. I think that's very important to be competent in debugging your programs. One of the faults, in my opinion, of C++ is when something wrong happens during runtime, it doesn't give you any message that's helpful to you. So then it makes your investigation more difficult. But that's kind of we just have to deal with that. So when you have a segmentation fault, a lot of times that's because of a null pointer reference in your code, or an invalid pointer reference in your code. So there's a couple of approaches we can take. One is use a step debugger to step through the code line by line and figure out which line of code the problem occurred. Another one is you put in some print statements, sprinkle some print statements in the program, and then try to gather information from those print statements as you execute the program. And then another approach would be, let's simplify the program so that the testing path is easier and more repeatable. I think what I'm going to do, probably a combination of a couple of things. First, I'm going to simplify this program. Instead of doing this main loop thing, and then I have to go through a series of user actions before I can test something out, I'm going to simplify it so that instead of running the main loop, I'm just going to, let me think. Currently, it just reads from the body. I think what I might be able to do is just parse top level expression. It's the only thing in the program. Whoopsies. It's the only thing in this program. That's supposed to be auto with a name. And then, I guess if that didn't work out, I'll say didn't work. Then no parse found. But if it did give us something, then we'll do this print out. The AST print with errors, which I don't really understand what the errors thing is doing. I'm just copying the code from here. Oh no, we need to code gen first. Whoopsies. Given the AST, we need to call the code gen on the AST node to get the IR representation, and then it's actually the IR representation from which we're gonna print. So we're gonna try this, run this program, but I think I can run this program, type in something, hit enter, and see the result, or I can type in a program, save in a file, and then pipe the file into this program. So let me rebuild this program now. I have a build script that I can just run to rebuild it. Okay, so I think I'm just gonna try doing it from the command line. Unknown token when expecting an expression already. Illegal instruction 4. Whoa. Was not expecting that at all. Illegal instruction 4? Illegal instruction 4 maybe unknown token. Unknown token. When expecting, so it got here. Interesting. So I'm gonna try to do, what I'm gonna try to do is make a file and pipe it in. So I'll call hello.kaleidoscope. Kaleidoscope KS. Let's say the first program is just 1 plus 1. I think that should be a valid expression. So I'm gonna cat, and Unix cat will print out the file, and we're gonna pipe that to the program. And we still get this error here. So I think we need to debug this. Let's go into this step debugger. Let me see. Oh, in order to use this step debugger, we need to make sure we build the program with debug mode on. So so I'm gonna remove I'll put the 2 comments on the top. So I do have debug mode turned on, so we're good. The -G means debug mode on. I think this optimization might make it a little harder maybe, but I'm gonna try it, and if it's still hard, I might lower the optimized level to 0 or 1. Anyway, I'm gonna how do I pipe stuff into it though? Although it kind of already happened though, even with not piping input into it. Maybe I'll just debug it like that. So I'll use LLDB to debug the program. Another module in the LLVM infrastructure. I have been using LLDB even just for coding in C and C++, so I'm quite familiar with how to use it. And I'm going to set a breakpoint. I'll find a line number. I'm going to say line 565. So I'll say B. I have to type in the name of my file, and then I'll say 500 and what was it? 565, and it set a breakpoint. And I'm going to use the R command to run the program, and it broke here, or it set a breakpoint here. I'm going to go into GUI mode. Oh, it said the target stopped. Huh. Okay. It skipped over the line that I wanted to stop at, actually. I wanted to stop here. Interesting. I thought it would have errored out already, because the error came from the parser. This is quite surprising to me, actually. So what is the FNAST? Let me look at that. So you can actually examine the variables down here. Although this is looking kind of gnarly, very dense. So FNAST is a unique pointer which contains a compressed pair Okay, within it, it's got a proto-ast in it, which is another unique pointer and has these compressed pairs in it. Oh, this is actually harder than I thought to navigate, because these data structures that we're using from the standard library is pretty complex in structure. Oh, finally we get to the name. And probably the value. Huh. I guess I'm gonna try to just step, and we hit an error. Invalid up when I try to step over the codegen function. So I'm gonna restart. I kind of want to verify that in fact I don't understand why it didn't pause on line 565 actually. That was confusing. I'm gonna try 564 just in case. And it still stopped here. Okay, I'm gonna step in. Stepping in gets me the error. So right now I'm thinking I should recompile it with a lower optimized level. And I think I have a better debugging experience if I did that. So let me rebuild it. I changed the optimization level to 0, so it won't try at all to do any optimization. Do that again. Now I set my breakpoint. I'll do it 565. Run it. And actually it stops at the right line. Thanks. Okay, so now we're at this parse line. And I'm gonna step into the parser. There it is. I expect this not to work because it's trying to read characters from standard input, and we don't have any standard input kind of set up. So I actually wonder what it's going to do. And what are we parsing a top level expression? Yeah, we are parsing a top level expression, which is just gonna call parse expression. So what is current token? What is the current token? Current token is 0, it looks like. Is that right? I'll step. It's an unknown token when expecting an expression. Current token. Wait. Did anyone even call get token? Get next token? Because if you're gonna call parse expression, there's parse definition. Parse top level expert doesn't call get token. Surprisingly, I thought that it would. And parse expression doesn't do it either. That might be a problem. And then parse primary also doesn't call get next token. So there's no one to call get next token. Oh wait. Oh, this just expects the current token to already be an identifier. So I think that might be the problem, or at least one of the problems. So I think what we need to do, and I'll look at their code. I'm suspecting that in their parse top level, probably, I don't see it though. Parse expression, I don't see it here either. Handle, maybe, oh, the main loop. Oh, I see, the main loop does a get the handle definition. No. I don't get it. Who is calling the get next token? Maybe we need to call get next token manually first. Oh, I see. Initially, there's just one call to get next token. Okay, so I'm just gonna put that here. Okay, let's try it again. I think that is something that definitely needed to happen. And we'll try again. Okay, I'm just gonna try in non-debug mode, and it seems like it's waiting for me to type in something now, which is good. So I'm gonna type in 1 + 1. It didn't seem to do anything. I think I might do a printout here. First AST. See if it ever finished parsing the AST. If there's an end of file character at all. 1 + 1. No, it didn't end up. Oh, it did say parsed AST, but then after that there was a sig fault. Parsed AST, maybe show this pointer. One + 1. I did parse an AST. It could be the code gen that went wrong. But how can we run this in the debugger? That's a question. We might be able to. Let me try it. LLDB mylang bin. Let me set a breakpoint at line 567. That's this line, because I want to step into the code gen. I suspect the code gen is actually the code that caused an error. So 567, and then I'm going to run it. And I think this allows me to type in my input, 1 + 1, enter. Oh, you know what? Maybe what I can do is get the parser to have a special character that tells it to stop, maybe? That might require a bit more work to do. Alright, I'm gonna try this. Oh, we did stop. Awesome. Alright, let me drop into my GUI. That worked. Okay, I'm stepping into the code gen. Yeah, okay. We're in business now, I think. These variables are still kind of hard to observe because they're wrapped within these unique pointer structures, which are kind of have a complicated structure. But then Well, let's just see. So we're actually calling CodeGen on a function AST. Oh, that actually makes sense because the top level parser always wraps the expression in this top level anonymous function. So yeah, it parses the expression, but it wraps it in this anonymous function that doesn't have a name. So that's why it's the top level AST node is actually a function. So we're gonna get a function. It looks like that's the point where it failed. Is that true? Yeah. And gave me the machine instruction. I'm not really good with machine code, but this means move Q. It moves, I think it moves the variable inside the address that it's contained in this register into that register. That's kind of what that's saying. And I guess I could look at this code, but I may not be able to make too much sense out of it. But I guess what I gathered based on that is that the line that actually caused the segmentation fault is the function's it's not in the parser, but it's in the CodeGen. It's in the functions CodeGen, I think. It's in the function definitions CodeGen method. Where is that? Where is that? I'm trying to find it. This is in the parser. Oh, the CodeGen stuff is higher up. Okay. Yes, it was this one. Maybe it's because proto is undefined. That's one possibility. Another possibility is maybe it was because the module was undefined. So let's see which one it is. We could actually print it out, but we could also just go back into the debugger. Not sure which one is faster, honestly. I'm just going back into the debugger. Up arrow a few times to get my breakpoint back. Run the program. Type in, I'm just going to type in 1 actually, instead of 1 plus 1 to simplify it. And then now we're in here. Go into GUI mode because I do like GUI mode. Let's look at now what is the value of the module. We have the context. Might need to make the text smaller so I can see more stuff. Let me try it again. Alright. Making the text smaller so I can see, have more real estate in the debugger. Okay, going into the GUI, going into the CodeGen function. Alright, now I want to look at the module. Where is the module? We have builder, we have this map. We have Kurtok. The module. Okay, we have the module. It's actually got stuff in it. Okay, it could be the proto is not defined. Oh, proto arrow get name. Did we ever write the get name function? Maybe that's what it is. What is proto? Do we have a proto? Proto. Oh, proto is it's an instance variable within the function, so it would be under this. Proto does have something in it. It's a unique pointer. Okay, that points to something that has a name, but I don't think I implemented the get name method for proto, honestly, and that might be the reason. There's a get name method defined, I don't remember implementing it. And in their code, they probably have it implemented. No. What? Oh, they just inlined it. They just inlined this to return name. Did I do that? Yeah, I did that too. Mine has it reversed. Does that matter? I don't think it matters, but also there's doesn't have the word virtual before this. I don't think that matters either, but you never know, I guess. How is mine different than theirs? Codegen. Theirs does work though. I have tested compiling their code and running their code, and theirs does work. And if you feel like skipping this part and just going to that part, yeah, by all means. I'll show a working version in the next video. And for this video, I'm just gonna spend the time trying to debug my version. So get name, I could try to, I could try to split it up and yeah, let me try this. I'm going to, not in here, but in here I'm gonna get the name into a separate variable, proto arrow get name. Got the name. So as a second step, I'll print out like defining function name, and then I'll say successfully got function pointer from the module. Alright, let me rebuild it and then run it. Okay, built. It's a defining function empty. Which makes sense because it is supposed to be an anonymous function, but calling the module get function. Oh, is it the module dot get function? It might be the module dot get function. Because the module, no, the module is a unique pointer actually. But the module get function did not work for some reason. So I'm gonna isolate it to this. So I'm just gonna have the program only do that. I'm gonna skip the whole parsing process and just isolate to, oh, come on. Why is my editor behaving this way? I'm gonna try to get the function like that and see if it's sig faults. I'm gonna print out something. Build it again and see if it's sig faults. It does sig fault. So that's actually a great result, even though you might not think that, because that probably means there's something about, oh, we need to do this. We did not instantiate the module. Holy crap. That was pretty important. Yeah, it turns out we needed to instantiate the module. We're gonna call the module my coolJit, apparently. Okay. Did they tell me to do that? Come on, man. I thought this was a step-by-step follow along. Driver code. So it's basically saying, hey, you know what? Just copy my code. Yeah, that's fine. Okay, so I think that is the line I was missing. Let me try it now. Okay, now I run it. Success. Okay, beautiful. Okay, so that was the line I was missing, and now I'm going to try this. My previous snippet. Oh, come on, VS Code. I have this auto-save feature on, and I swear I'm gonna turn it off very, very soon. Okay. It's really bothering me right now. Okay. I'm gonna try to type some code in, and then it's going to, if we're lucky, generate the IR version of that code. Yes, it worked. Oh my god, that's freaking awesome. So basically I typed in a 1. My program, the text of my program, my entire program is 1, and then it translated that program in the Kaleidoscope language. It translated that program in the language of LLVM IR, and the code in LLVM IR looks exactly like that, and is saying I'm gonna define a function that returns a double. We'll call the function @0 for some reason, and it has 0 arguments, and then it has a body which is called entry, and it's gonna return a double, and the value it's gonna return is 1. So that worked, and I'm gonna revert this code back to this main loop and play with it a little bit, and then in the next I'll stop this video, and then in the next video I will play with the REPL a little bit. So I'm gonna need to instantiate the module first, as it turns out, and then I'm gonna run the main loop. Okay, now let's run it. Okay, so that's the REPL. Let me make the text bigger again. So we already did the 1. Okay, so 1 gives us this program. Successfully got point. Maybe I should remove define double read top level expression. Where does it say read top level expression? Okay. Maybe I do a new line here. Red tab level. This is red extern, red function definition, and I'll get rid of my extra print statements. Okay, I'm gonna recompile the program and then do the REPL one more time. Okay, 1 plus 1 semicolon, and then it actually has smartly pre-added the 1 plus 1. Okay, so great, the REPL works. I'm gonna stop this video here. In the next one we'll play some more with the REPL.